All right. So in this video, we are going to talk about loan repayment methods. This is module 3, and we are going to learn about what are the techniques we can use to pay the loan. So loan repayments. So there are actual two methods for our exam FM class. The amortization method and the sinking fund method. The sinking fund method is actually not covered in new exam FM. They changed the syllabus a little bit. So we are really going to focus on the first method, the amortization method. So loan is an arrangement in which a lender gives money or property to a borrower, and the borrower agrees to pay the property or repay the money, usually along with interest, at some future point in time. Then you have these two methods. So under amortization method, your payment is basically constitute two parts, basically principal and interest. The idea is your payment is bigger than the, so basically your payment is bigger than the interest. Okay, so this would be your total payment. That's the total monthly payment. Then you would make a payment which is bigger than required of the interest on current balance. Okay, so this would be more than interest. So if this is true, then you can pay off the loan. But if your payment is less than interest due, or the interest amount you have to pay out, then what's going to happen? You are going to be in a situation where we call the negative amortization, where you will not be able to pay off the loan. Also, your principal amount will increase. The sinking fund method, in here you have actually two payments. Okay, so the payment one to cover interest. Okay. So what that mean? You will cover the interest. You will pay the interest due for that that time period. Then you will make another payment two, to another sinking fund. Okay. So then this one would be accumulate. So once accumulated value equal original loan amount borrowed, since you are paying the interest, the loan amount is still at the same level, original loan amount borrowed. Then you can pay off the loan. So, but we are not going to really cover the sinking fund method, only the amortization method. So the amortization method, in this method, the borrower makes installment payment to the lender. Usually these payments are at regular spaced periodic interval, like the mortgage payments. Every month you will make a payment. The progressive reduction of the amount owed is described as the amortization of the loan. So progressive reduction of the amount owed is called as the amortization of the loan. So this is only happen if you pay more than the interest due. Okay? The fundamental principle behind the amortization method is when a payment made, it must be first applied to pay interest due. So that's why you have to, your payment must be bigger than interest due, otherwise you will not be able to pay off the loan. And then any remaining part of the payment is applied to pay principal. Okay? So it's not the other way. So when you make a payment, it's not going to first apply to pay principal. It's going to be first apply to the interest due. Once interest is paid, then whatever the leftover left amount, that will be used to pay the principal. So here you can see an example. This one says Troy took out a loan for $2,000. The loan was governed by compound interest at rate 5%. He made a payment of $800 1 year later and payment of $1,000 3 years after he took out the loan. Find the amount of principal in each payment and Troy outstanding balance immediately after second payment. So the way to do this, you can create a table. Okay, so let's create a amortization table. Period. Then the payment amount. Then the interest paid. Then the principal prepaid. And then the outstanding loan balance. So at time 0, we are borrowing money. So the borrowed money is $2,000. Okay. So end of the year 1, a payment is made. So what is the payment? $800. So what is the interest due? So interest due after first year at the end of year 1. Okay, so so that's going to be 2,000 times the rate. Rate is 5%. Okay, so this is annual effective rate. So 5%. That's going to be $100. Okay, so then the payment 800 first apply to the pay interest. So you will first pay interest, which is 100. Then the principal the left, what the remaining, so 700. So when you can see that when you add these two, it's going to be 800. Okay, so when you add 100 interest paid and principal repaid, it's going to be the payment amount. So you repaid the principal 700, so the remaining balance would be 1,300. So how I got that? 2,000 minus 700, you get 1,300. So then come the end of the second year. 1 year later, and the payment of 1,003 after took out the loan. So the second year there's no payment. Okay, so there's no payment, but interest due. So how much interest due? 1,300 times 5%. So that would give you what? Use your calculator. That would be $65. So interest not paid. Actually, this would be due. Okay, because we never paid this. 65. So there's no principal repaid. So now your outstanding balance is going to be increased because you didn't pay the interest. So it's going to be 1,365. Okay. Then the third year comes. At the end of the third year, the payment was made $1,000. And then by that time, he was making that, the person making that $1,000 payment, what was the interest due? So we can calculate 1,365 times 5%. That would be $68.25. Okay. So now you can apply that $1,000 into this this interest payment, and then see how much you are paying principal. So 1,000 minus $68.25, that would be 931.75. So then what will be the remaining? So you take 1365 and you subtract the principal repaid, and then you would get the outstanding loan balance. So 1365 minus that would be 433 and 25 cents. So find the amount of principal in each payment and throw your outstanding loan balance immediately after second payment. So the second payment is at the end of the third year. Okay, so immediately after the payment, the loan balance is $433.25. Okay, so this is the balance after second payment, not the after second year. Okay, second payment. So that's how you calculate the principal repaid, outstanding loan balance, and those terms. Here's another example. The amortization schedule. An amortization schedule is a chart that shows the time and amount of each payment, the division of the payment in interest and principal, and the outstanding loan balance immediately after each payment. So that's what we did here. Okay. So this is that table. So here's another example. Troy took out $2,000. The loan was governed by compound interest at rate 5%. He made payment of 800 1 year later and payment 103 after. Suppose that he makes an addition payment 4 years after the first time of the loan, so that loan is able to make an average for this loan. So we will get the same table like this one, but then we had to make the fourth another row to find out what would be the final payment. Okay, so actually yeah, so let's make the table. Let me copy this one. So I'm going to come here and I'm going to paste that chart. Okay, a bit smaller. Okay. So now we can go for the fourth year. Okay, so let me draw it. So here fourth year. So what would be the final payment? So you can see that so I have to calculate the interest due at the end of the fourth year, because this payment is going to be made at end of fourth year. So 433.25 at the end of the third year time 1.05, that would be the total payment due. So you calculate this. So 454.9125. So that should be the total payment the person going to make. So how it's going to be divided? So first the interest portion. That would be $21.6625. And then the rest would be when you take out that from the payment, the principal repaid would be 433.25, and then the remaining payment would be 0. So we paid off the loan. Okay, but we had to make a payment of this much at the end of the fourth year to pay off the loan. Okay, so here's another example. Gerard borrows 20,000 at an annual effective discount rate of 4.8. The loan is to be repaid by annual end of year payment for 4 years, the first three of which are for amount of 5,645.75, and the time for payment is for that. Make an amortization schedule. So let's see how this is going to work. So here I have the period. Here is the payment amount. Here is the interest paid. Here is the principal repaid. And then the last one would be outstanding loan balance. Outstanding loan balance. Okay, so at the first one, just the loan. Then the payment is basically at the end of the first year. Payment is 5,645 and 75 cents. How much interest do you? 20,000 at rate of 4.8. So that would be what? That would be 960. Then you apply the payment amount to first interest paid, then the principal repaid. So you take the difference, 5,645 and 75 cents minus 960, and you are paying 4,685 and 75 cents principal amount. So the remaining loan balance will be 20,000 minus that. 20,000 minus 4,685 dollar and 75 cents. So you would get 15,314 and 25. As then it comes to the next one. So again, the payment amount is 5,645 and 75 cents. Let's calculate the interest due. 15,314 and 25 times 4.8%. So interest due, that's going to be 735 and 0.84. Then the principal repaid, you take the payment amount, 5,645, and subtract that, and it would be 4,910 dollar and 666. And the remaining loan balance would be 10,403 and 584. Let's go to the third one. So let's calculate the interest due times 4.8%. So let's calculate them. And it's 419, 99 and 372032, and the payment is. So let's check the difference to see how much we pay off the loan and the principal repaid in the payment. It's 5,146 and 377,968. And then let's take the 10,000 minus that, 10,003 minus that, that would be show us the outstanding balance. So that's 5,257 and 206032. And the last payment, the payment amount is 5,645 and 72 cents. So let's see the interest due. So we multiply this by 0.048, and I would get $252 and 3458895, and then take the difference and see what would be the 5,004. Wait, I think I made a mistake. So yeah, so I have to take the $5,645 and 62 minus this. So this would be $5,393.3741. So we are going to, when we try to pay off the loan, so you can see because this is bigger than this one. So that means basically we will have some money left off, left left in the account. So we can make the payment. We can save some money. Oh, by the way, I didn't notice the discount rate. So actually, you cannot multiply by 4.8. You have to convert it to rate. So redo the problem because this is discount, not the interest rate. So that's why actually it's not exactly matching. So convert this to interest first. So how you do that? 1 minus d times 1 plus I equal 1, and you get the rate. Okay, so then use the rate. So you can't use the 4.8. You have to use the rate. Okay, so anyway, you get the idea how to make this kind of table. So now we want to introduce some notation. So here you can see few notations. So we have the loan payment at time K, which is payment K. Loan balance after payment K is BK. Original loan amount B0. Interest paid in payment K is IK plus 1, which is I time BK. Principal paid in payment K plus 1 is payment K plus 1 minus interest in that payment. In outstanding loan balance after payment K plus 1 is BK plus 1, which is previous BK minus principal paid on the K plus 1 payment. So, so you can apply that idea into here. So you can see if you make level payments, you can really start to come up with use these annuity formulas. So let's see. So let's say you are making you borrowed loan for n years, okay, and then your payments are $1. Okay, so this is how you repay the loan. Okay, payment. So then what would be your initial loan balance? So B0. So that would be the present value of this $1. No? So basically B0 is V, and then the next one is $1, but you have to multiply by V square to discount it all the way up to Vn, the last one. Okay. We have a symbol for this. This annuity immediate, no? Under rate I. Let's say the rate is I. Okay. So that's why here you can see the outstanding loan balance is AN. Okay. Then you make up. So so what is this formula? This is 1 minus V to the N over I. No, that's our initial loan balance. So then we make a payment. Before that, let's talk about the interest due. Is what? I time V0 for the first one. Okay. So in here, this one. So this would be 1. So this is V0. And then this is I time V0. So I can use the formula. And I would get 1 minus V. Okay, so that's why you have here 1 minus V. So then the principal repaid, what's the formula? What's the notation? Payment 1. Okay, so that's the first payment. This one is the I1 interest. So this is I1. Then not the payment. This would be P. The payment is this one. This is what we got the payment. So this one is then the principal. Sometimes you use P, sometimes we use PR. Okay, so depend on what you like. So this is PR1. So what's the principal repaid in the first payment is payment amount minus I1 So that would be 1 minus Vn, which is Vn. Okay, so that's why you will see this Vn. Then what is the outstanding loan balance after the payment one? So this is called the B1. So B1 is you can see here, okay, and that's basically the previous loan balance minus the principal repaid. Okay, so this is, you can say, previous outstanding loan balance minus principal repaid. The previous one is B0 for us. Then the principal repaid is just Vn. So I can use the formula. This is 1 minus Vn over I minus Vn. So this is 1. This is 1 minus Vn and I minus 1 plus I to the Vn over I, which is going to be, remember 1 plus I times V is 1. So this is going to be 1 minus V to the n minus 1 over I, which is basically an minus 1. That's why we have this an minus 1. The reason here, because 1 plus I times V is 1. So that's why you get n minus 1 instead of V. Okay, so so you can continue like that, and you can create this nice table. So in here you can eventually you can see a pattern. Okay, so what's the interest paid in payment? It's payment time 1 minus V to the n minus k plus 1. So you can see n minus 1, n minus k plus 1. This is just $1. If you have k, the payment size is this, then you have to multiply with the payment size. Okay. So if it is $1, then you have 1 minus V to the n minus k plus 1. But if you have PMT size, then you multiply by that. Also, the principal you can see here Vn minus 1, Vn minus k plus 1. So this is the general pattern. Okay. Now, if you add these two, what do you get? Should be payment. Okay. Can add these two and see. Then also you can see the principal amount in the n plus k is 1 plus I to the k times Pn. Okay, this is very nice. Assuming level payment, okay. Assumption. If that's not true, then this is not true. Okay. Then also outstanding loan balance after k payment is this one. We are going to learn about this approach. This is called the prospective method to see the future and the remaining loan balance. Okay, so here we can see example, 5,000 loan is being repaid by payment of X at the end of each half year for as long as necessary until a smaller final payment is made. The nominal rate of interest convertible semi-annual is 40%. So if I draw the timeline, so you can see right away the rate is 14% now. It's nominal. So that means this is nominal. So then the effective rate for 6 months is 7%. This is I2 divided by 2. What is this? This is effective rate for 6 months. Now the payments are, this one is 5,000. Payments are X. So the first one is if X is 4,000, find the amount of principal and the interest in the 6th payment. So they are saying if X is 4,000, 400, find the amount of principal and interest in the 6th payment. So So we can come here and then we can use one of these formula, okay, to answer that. So let's try to answer the sixth payment. So I want to see the I6, which is basically payment time 1 minus v to the n. So we need to find the n minus 6 plus 1. Okay. And then the P6 is payment time 1 minus, not 1 minus, just v. Okay. By the way, when you add these two, you should get 400. Okay. So actually, you can calculate only one and then get the other from subtracting that. Okay, let's calculate this one. This one look easy. The other one we can take the form 100 minus that and then we get the interest. Okay. Okay, so what would be the so let's calculate n. So how do we calculate n? Use this is annuity, so we know the present value is 5,000 and payment is 400. Compounding per year. I'm thinking the 6 month as year, so compounding per year is 1. Payment per year is 1. Okay, and then the rate would be 7%. Okay. Now remember, my year is actually 6 months, not really. It's just 6 months. Okay. Then I would get how many 6 months? Yes. Okay. So the n is what I need. So let's use our calculator. So second reset. Okay. Present value is 5,000. And I'm making payment, so it's kind of like out of my pocket, so it's negative 400. Then the rate is 7%. And then second IOY, and then payment per year is 1, compounding per year is 1. Future value is 0. 0 for future value. And then compute n. So 30.73. So n would be 30.73. So that means what? That means you have full 30 payment. So this means what? This means basically n equal 31. So what that means, 30 payments of $400 and 31st payment less than 400. So that's how you are going to pay, because you need more than that. So now we know the n equal 31. So let's calculate the I6 and P6. So payment is going to be 400. P to the n is 31 minus 6 plus 1. And then here 400 v to the 31 minus 6 plus 1. What is v? V is 1 over 1 plus 7%. Okay. Negative 31 minus 6 plus 1. That's going to be 26. So that would give you the P6. So if I solve this, that would be the $68 and 878. And then the interest would be 400 minus that. Yeah, 31. If payment is 350, find the principal in the sixth payment and interpret this. So if payment is 350, let's see what's going to happen. So now the same thing, but in here I'm going to enter 350. Okay. And then first I need to find the how many years it's going to take pay off this loan. The payment is 350. Is negative. And then rate is 7%. This is 1. Future value is 0. And then compute and step. Maybe we need enter versus. By the way, let's see the minimum interest due each payment. 5,000 times 7%, no? So at the end of the each term, you have to pay 350. Now the payment amount itself is 350. So you are not really going to pay off the loan. Okay, so this is the interest due. That's why you say the error. 350. This is at the end of each at the end of each term, at the end of each 6 months. The interest due 350, and you are making a payment of 350. So it's just to cover the interest due. So principal in the sixth payment is 0. So interpret this. Yeah, you will never pay off the loan. Okay, so let's try to do this problem. In this one, Seth borrows X for 4 years at an annual rate of 8% to be repaid with equal payment at the end of each year. The outstanding loan balance at the end of the second year is this one. At the end of the third year is this one. Calculate the principal repaid in the first payment. Okay, so outstanding loan balance at the end of the second year. So this is okay. So so how do you get the outstanding loan balance? We can use one of these formula. Okay, so how do we connect B2 and B3? If you look at this one, so you can say what? B3 is 3 minus 3 minus B2 time I. It's the end of the second year loan balance, and this is the principal, the interest due. Then the B2 We can use this formula actually. Oh, that will be the easier one. Rather than use. So what is B3? B3 is payment time A. So how many payments we are going to make? 4 years. Okay, N minus K. So that's the. Then the B2 is payment A4 minus 2. Yes, that's equation 1. This is equation 2. So if I divide 1 by 2, and by the way, B3 I know the value. So 1076. And then B2 I know the value. Oh, B3 is the 559. And B2 is 1000. So if I divide 1 by 2, I would get 559.12 over 1006.82. So this will cancel out when you divide 1 by 2, and then here you get A1 over A2. Okay, what is A1? 1 minus V over I. What is A2? 1 minus V square over I. So I cancel out. And so let's divide 159. This number, let's get the answer. 159.12 divide by 1076. Right. So it's going to be 0.51923255. You will get 1 minus V over 1 minus V square. So now this one, 1 minus V, 1 minus V square you can expand. That's the cancel out. So you get 0.51923255 equal 1 over 1 plus V. So from here you can solve for V, and from V you can get I. Let's solve for this one. So you get 1 plus V equal 1 over this. You would get 1.92591930, and then you would get V is 0.9259193, and then V equal 1 over 1 plus I. So if you then I is from here, you can solve for I is going to be 0.08. Okay, nice answer. Okay, so if you know I, then you can calculate the principal repaid in the first payment. So what is the so let's calculate the payment size now. So I can use the equation 1, let's say. 1 says what? 1 says 159.12 equal A1, which is the payment time A1. What is A1? A1 is 1 minus V over I, time payment. From here, you can solve for the payment. So let's try to get the answer. So 1 minus V is 0.92 divided by I is 0.08. And then you divide 159.12 by that. And then you would get payment as 603. 5, 6. So you calculate this quantity and then divide 559.12 by that. Okay, so that's the payment size. Then calculate the principal repaid in the first payment. So that's now you can go back to one of these formula. Principal paid in the first one. P1 is payment time V n minus K plus 1. So P1 is payment time e to the n minus k plus 1. And the payment is 603, 7956. V value, you know, n is 4. Four minus 1 plus 1. So you can go to answer. Okay, so I'm going to leave this question for you to try. And then we will meet again in the next lecture.